30 students. Okay, so check your work. And if you have any questions, feel free to ask me in class. We're now going to look at the permutation formula, how to calculate permutations mathematically. So what you're going to see is something that looks like this, NPR. Okay? And NPR means a permutation of n objects chosen R at a time. Okay, for example, let's say I have 5 people, okay, and I want to arrange them in groups of 3 where the order matters. Okay, so I'm going to choose sets of 3. Okay, so what we would have is 5p3. And the way we solve this is using this permutation formula below. N factorial over n minus r factorial. So we're not going to go into where that comes from right now, but I want you to know how to use the formula. So let's try a few. 5p3, we would have 5 factorial over 5 minus 3 factorial. And so what we can write is 5 times 4, 3 times 2 times 1, over this bottom number, which became 2 factorial. And that would just be 2 times 1. And from there we can just cross out the 2 times 1 and calculate our final answer, which would be 60. Okay. Pause the video, you guys try 10p8. Okay, and I will tell you that 10p8 comes out to be a very large number. Oops, did I make a mistake here? I did make a mistake. Okay, it's not 8 factorial. Okay, it is 10 minus 8 factorial. So this is really 10 factorial over 2 factorial. Okay, which is 10, 9, 8, 7, 6, 5, 4, 3, 2 over 2 times 1. So we're going to cross out the 2. And we're left with 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. I'll let you use calculator on that to get the big number. Okay. So where is this useful? Let's say that we have 12 players on a softball team. How many different batting orders of 9 can be formed? Well, we already said that the order of baseball players matters in a lineup. So what we're going to do is we're going to start with 12, and we're going to choose 9 of them to permutate. So we'd have 12 factorial over 12 minus 9 factorial. Okay, or 12 factorial over 3 factorial. Okay, and I'm going to let you guys make that final calculation and check with each other. I will tell you it's a very large number. What about this one? We have 35 numbers on a lock. Okay, and we need to select 3. How many different lock codes are there? Okay, well, does the order of the numbers matter? Yes, it does. This is actually an interesting English question because most people say locker combination, but it's wrong. It should be locker permutation because the order of the numbers matters. So we're going to do 35 permutate 3. Okay, so we would have 35 factorial over 35 minus 3 factorial. And we don't have to write every number out here because that would take forever. We can write a few of them, dot, dot, dot. Because we know that on the denominator here, we're going to have 35 minus 3, which is 32 factorial, 31 dot, dot, dot. And all those bottom numbers are going to cancel out. And I'm left with 35 times 34 times 33. So what's that going to be? Let's take a minute and look. I got 39,000. Let's see, I got 39,270. And that would be if there are 35 numbers. Looks like this particular lock in the picture has more, like 36, 7, 8, 8, 9, and then counting 0 would have 40. So if we were doing it for this particular lock, it really should be 40 P3, but for the example, the word problem, we would go 35 P3. So you can imagine just trying to guess a code, you'd have a 1 in 39,270 chance of getting it right. Now let's look at the combination formula. So NCR means a combination of n objects chosen R at a time. Okay, and remember with this, we're not concerned about order. In other words, like ABC is equivalent to BCA, is equivalent to ACB, etc. They're all the same group. So what we have to do is we have to divide by this R factorial term. And what that does is it divides out the repeats. Okay, so it takes care of the repeats that you get from like ABC, BCA, ACB. So let's do an example, 5C3. Okay, so that's going to be 5 factorial over 5 minus 3 factorial times 3 factorial. So we're going to get 5 factorial over 2 factorial, 3 factorial. And we're going to have 5 times 4 times 3 times 2 times 1 over 2 times 1, 3 times 2 times 1. And here you can see what happens. We cancel out what we can. And then we're left with 20 over 2, which is just 10. Okay. Let's also do the next one. This would be 4 factorial over 4 minus 4 factorial, 4 factorial. And we get 4 factorial over 0 factorial, 4 factorial. So this is where that 0 factorial comes into play, because we don't want a 0 in the denominator. So mathematicians define 0 factorial to be 1. So what we get is 4 factorial over 4 factorial. And our answer is just 1. What do you guys think is bigger, 5P3 or 5C3? Okay, pause the video, discuss with your neighbors. Five P3 would be way bigger because we have more choices. Okay, 5C3 gets rid of all the repeats. Okay, so it's going to be much smaller. Okay, so a pizza allows users to select 3 toppings from a list of 20. How many different pizzas are there at this restaurant? Okay, so this is going to be a combination problem. Hey, combination pizza, right? There you go. So we're going to have 20 C3. Okay, I'm going to let you guys try the math on this one. All right, guys, so we're at the point where I'm going to have you start your homework handout. It's the day 10 handout. And There are 3 different levels, a front and back page. When you've completed each section, ask the sub to come over and sign off on each section. Okay? And the answers are also online, so you can check your work and make corrections. Remember, you have to show that you've made corrections for full credit. Okay? Thanks for watching this lesson. This is Virtual Mr. B, signing out.